Hello, in this video we'll go over how to find the area of a polar curve and how to find the area enclosed by two polar curves. Finally, we will go over how to find the length of the finally we'll go over how the length or the total distance of a polar curve. So area and polar coordinates. As you can see, if we create here's a polar graph, uh, and it somehow creates a wedge that looks like a triangle, and we'll find the area of that. So yeah, here's this wedge which creates a triangle, and then you have the radius, and then you have this leg which is r times d theta. And we know that the area of a triangle is 1/2 base times height. So dA would be 1/2. So if you compare it with this triangle, um, the base is r times d theta, and then the height is the radius, which simplifies as 1/2 r squared d theta. Okay. So area, to find the area, you would integrate both sides. So yeah, integration of dA equals the integration of 1/2 r squared d theta, which from the integrals a to b, and somehow you get this area equals 1/2 from the integration a to b of r squared minus small r squared d theta, or you could think of it as the outer minus the inner. So if you have a rose curve, you just have to make sure that you draw one petal at a time. Okay, let's do an example one. So example one says find the area of the polar function when given r equals square root of sine theta from 0 to 2 pi. Okay, so what do we know? We know that the area is equal to 1/2 um, from lower limit to upper limit of r squared d theta. We have everything we need. We have our r, and we have our boundaries, right? I believe our a is 0, and our b is 2 theta, and my r is square root of sine theta. So it's going to be a equals 1/2, and then 0 to 2 pi. R is, so what would r squared be? You would square this and the radical disappears, so you're just left with sine theta. Okay, and then don't forget you still have this d theta, so it's going to be sine theta d theta. And what is the integration of sine theta? It is negative cosine theta. And then you still have to bring this 1/2. Well, you could bring that out later. Then you could just apply fundamental theorem, right? Lower, you apply upper minus lower. So this would be negative cosine of 2 pi minus bracket negative cosine of 0. And then don't forget we took out this 1/2. So what is a negative cosine of 2 pi? It is 1. So wait, so this would be negative 1/2 cosine of 2 pi minus cosine of 0. And when you get all, this is negative 1/2. Cosine of 2 pi is 1 minus cosine of 0 is also 1. And this becomes 0 times negative 1/2. So the area is 0. Okay, go ahead and copy. Okay, let's move on. Okay, example 2 says find the area of the polar function r equals 2 plus 2 cosine theta. So what does that look like? That is a cardioid, and it would look like this. Okay, so yeah, we have everything we need. So the area is a equals 1/2 from the integrals 0. Oh, do they give us integral? No. Since okay, so since we're going around the circle once, it's just going to be 0 to pi. Actually, no, actually, in example 2, the theta is still from 0 to pi. That was part of the problem. So this is still part of the problem. We're still going from 0 to 2 pi. That's given. Yeah, so it's going to be, if r is this, what is r square? R square is going to be 2 plus 2 cosine theta times 2 plus 2 cosine theta. And when you put it all together, you're going to get 4 plus 8 cosine theta plus 4 cosine square theta. Okay, so this, when you square this, it's going to give you 4 plus 8 cosine theta plus 4 cosine square theta d theta. Okay, then we have to use your identities. Do we know any identities? Yes. 4 cosine square is an half angle. So if you took out the 4, it's just going to be 4 and then 1/2 plus 1/2 cosine 2 theta. And when you FOIL that 4 out, so this is 1/2 plus 1/2 cosine squared. That's in a half angle identity. So when you FOIL out this 4, it's going to be 2 plus 2 cosine 2 theta. Okay, so area equals 1/2 from the integral 0 to 2 pi. And you get, when you simplify this, you get 4 plus 8 cosine theta plus 2 plus 2 cosine of 2 theta. And then if you simplify it anymore, it simplifies as, you can collect the 4 and the 2. So it would be a equals 1/2. plus 2 is 6, plus 8 cosine theta, plus 2 cosine. Oh, let's go. And then you can just take the integration of each term. Right here, I guess you could use one of your identities. I guess this right here can be simplified as, wait, no, let's just take the integration of each term. So what's the integration? 6, it's 6 theta. What's the integration of 8 cosine theta? Well, the integration of cosine theta is sine theta, positive sine theta, and then bring down the constant. So that would be positive 8 sine theta. And what is the integration of cosine 2 theta? Cosine of 2 theta, it is going to be sine. So you kind of do use substitution, right? You do use substitution. You get sine of 2 theta. Okay, and then you still have this 1/2. Great, you still have this 1/2. And then you just apply fundamental theorem. So lower, upper, right? So you do the upper minus the lower. So when you put that in, it's going to be 1/2 bracket 6, and then replace theta with 2 pi. Minus the lower boundary. So this would be, I think when you plug in 0, this is 0, sine of 0, sine of 0, 0, 0. So this is all just becomes 0, right? And when you do the work, this is going to be 1/2. And then over here, when you do all the work, you should get 12 pi minus 0. And final answer is area equals to 6 pi. Okay, there's your final answer. Okay, so let's move on to example for you. And find the area of the polar function r equals 2 sine theta. Find the area of the polar function r equals 2 sine of 2 theta. So this is definitely a rose curve. And there will be 4 petals. So if we have a rose curve, we have to calculate one petal at a time. Okay, so it might look like this. Okay, so we have to just take the area of one petal, and then we could just times that by 4. So to find the limit, you set r equals 0. Okay, so to find our boundaries, you set r to 0. So to find limit or boundaries, we simply set r equals 0. So if r equals 2 sine of 2 theta, set that to 0. So it's going to be 2 sine of 2 theta equals 0. And then divide this by 2. Right, get rid of this 2 by dividing both sides by 2. You get sine 2 theta equals to 0 divided by 2 is 0. Then maybe you get rid of this sine by multiplying both sides by sin inverse. So this cancels, and then you're left with 2 theta equals to sin inverse of 0. So what that means is what degree in radians is going to give you a sine or a y-coordinate of 0? Well, there's should be 3. 0, pi, and 2 pi, right? And then all you got to do is get rid of this extra 2 by dividing both sides by 2. Everything by 2, right? So theta is equal to 0, pi halves, and then this 2 cancels, so you're left with pi. So really, remember we're going from lower to upper, so which one is more, what degree is more higher? The pi, right? So really it's just a 0 to pi halves, right? Because you go from lower to the highest boundary, so our highest is pi and our lowest is 0. Okay, so our boundary is from 0 to pi halves. Now we can plug it in. So area equals 1/2 from the boundaries a to b of r squared d theta. Let's see here. We have r, which is 2 sine of theta. So r squared is going to be 2 sine of 2 theta squared. So this is going to give you the area of one petal, not 4. Okay, so let's try to simplify this. So this is going to be a equals 1/2 from 0 to pi halves. And when you FOIL this out, you should get 16 cosine square of x plus sine square x dx. And this is an identity. I guess you can take out this 16, right? 16 is a constant, so 16, put that in, and then you still have this 1/2. So now you're left with cosine square of x times sine square of x dx. And I guess this right here simplifies as one of your identity. It would be simplified as wait, so over here 16 times 1/2 is 8. And then this right here would be simplified as 1 minus cosine 4x all over 8 dx. And then what you do is this is 8 is a constant, or 1 over 8. You could bring that out. So you still have this extra 8 and then bring out the 1/8. That's 0. And when you simplify it, you're going to get, when you simplify this, right, you know, the integration of 1 is theta. And so when you do all the work, you're going to get pi halves. And then this cancels. And then this is only one petal, so you have to times it by 4. So you get 4 pi over 2, and that gives you 2 pi. Cool. I'm not going to do this integration because you should know how to integrate this. Okay, let's move on to example 4. So example 4 says find the area of the polar function where r equals 5 and sine theta. So first we got to find the boundaries, right? So what is this? Well, what does it look like? It's a rose with only one petal. So it might look like this. Okay, so first step is find the limit by setting r equals 0. So it's going to be 5 sine of theta equals to 0. And then get rid of this 5 by dividing both sides by 5. You get sine theta to 0. And then if you multiply both sides by sine inverse, you're going to get theta equals sine inverse of 0. What degree in radians gives you a sine of 0? That would be from 0 to pi. And so our lower boundary is 0 and our upper boundary is pi. So it's going to be a equals 1/2 from 0 to pi. And then what was our r? Our r was 5 sine theta. So r square would be so you can just do it like this: 5 sine theta square d theta, and you could do use substitution, and you will get, so when you do the work and you apply the upper and lower boundary, I'm not going to show you this because you should know how to take the integration of this. You should get pi halves, and then you still have this 1/2. So your final answer is pi fourths. Let's move on. Example 5b. So this is still part of example 5. There's just a part B. Oh, so part B says find the area inside the cardioid outside of the circle. So it's the same problem, r equals 1 plus cosine theta and r equals 3 halves. The only difference is in part B, we have to find the area of the cardioid and outside of the circle. No. So yeah. Whoops. I think, what did I do? What problem did I do? I think I did. Oh, it's just example 4. Okay, never mind. This is why I was, okay, so that was just example 4. Example 5 is a three-part question. It says find the area of the polar function. Part A says given r equals 1 plus cosine theta and r equals 3 halves, find the area outside of the cardioid and inside the circle. So let's do that. And then part B says find the area inside the cardioid and outside the circle. And part C says find the area inside the cardioid and inside the circle. Okay, so let's do part A first. So part A says r equals 1 plus cosine theta and r equals 3 halves. Find the area outside the cardioid and inside the circle. So yeah. So did you know r equals 3 half is a circle and r equals 1 plus cosine theta is a cardioid? It might it might help if you drew the image. So it would look something like this. Okay, so the cardioid r plus r equals 1 plus cosine theta, that would look something like this. And then the circle would look something like this. Okay, so what we have to do is find it intersects here and it intersects there. So the first step 1 I would do is find points of intersection by setting the equation to each other. Okay, so it's going to be 1 plus cosine theta equals the 3 halves, and then just solve for theta. So maybe I would subtract 1 from both sides. This cancels. You're left with cosine theta equals 3 halves minus 1 half. I mean, 3 halves minus 1 simplifies as 1 half. Then maybe get rid of that cosine by multiplying both sides by cosine inverse. So over here, this cancels, so you're just left with theta equals the cosine inverse of 1 half. And where's degree in radians? That gives you cosine positive 1 half. You get theta equals to pi thirds and pi over 3. Okay, so if you want to draw an image, it would look something like this. So pi over 3 would be somewhere around here. And 5 pi over 3 would be somewhere around here. And if you draw a circle, because remember we have a circle. What we're trying to do is find the area of this part right here. That's what we're trying to do. Okay, but do you see our boundary? And we have to do a lower and an upper boundary, right? Oh, okay. Uh, so your upper boundary would be 5 pi over 3, and your lower would be pi over 3. Okay, that works. Okay, so this is what we're trying to take the area of. So now we can use our formula. Area equals 1/2 from A to B, lower to upper. And then it's going to be outer squared minus inner square of d theta. Okay, so that's going to be A equals 1/2. And then my lower is pi over 3. And my upper is 5 pi over 3. And what is my outer? It's a circle, so that would be 3/2 squared minus, what's my inner? The cardioid, right? So that would be minus 1 plus cosine theta squared d theta. So when you simplify this, this is going to be pi thirds, 5 pi over 3. This is 1/2. And then 3/2 is technically 9/4 minus this. So when you do all the work, you're going to get, you should know your integration rules. So I'm going to just give you the answer. So it's going to be, so you have this 1/2 here, and then you're going to get 3 pi plus 2 radical 3 minus 8 pi minus radical 3, 4. And this is going to be 1/2 times, when you put this all in the calculator, you should get 1.038, and that is about 3.519. Okay, so I kind of skipped this step because you should know how to do this. I'm not going to waste yeah, it's just to save time. I'm just going to give you the answer. And yeah, that's your answer. Okay, now let's do part B, 5B. So part B says given R equals, let me rewrite the problem, given R equals 1 plus cosine theta and R equals 3/2. Find area inside the cardioid. And outside. Okay. So this time it's going to be outer minus inner. So it's big R square minus small r square of d theta. Or you could think of it as outer squared minus inner squared d theta. Okay, so if you want to draw an image, it would look something like this. Okay, here's your cardioid, and here's a circle. And so what we're doing is trying to find the area of this shaded region. It looks like a crescent moon. So it's just outer minus inner. So it's going to be, if I set it up like this. Now, the thing is, this was 5 pi over 3, and then this is pi over 3. Because we have to do lower minus upper, you could also think of 5 pi over 3 as negative pi over 3. So our lower boundary could also be expressed as negative pi over 3, and our upper could be expressed as pi over 3, right? And then it's going to be outer, which is the cardioid, minus the circle, which is 3/2 square d theta. Okay, so when you FOIL this out, you're going to get 1 plus 2 cosine theta plus cosine square theta minus 9/2 d theta. And then you should know how to integrate all this, and you should get, to save us time, I'm just going to give you the answer. It's going to be square root 3 plus negative 20 pi plus radical 8 over 8 plus 2. And then when you do the work, or when you put this inside the calculator, it's going to be 1/2 times negative 3.90542, which is about negative 1.95. Okay, here you go. Okay, let's do part C. Part C is, I'll write the problem again. So you're given this same cardioid. Radius is 3/2. This time in part C, they want to find the area inside the cardioid and outside the circle. Okay, so if you want an image, it would look something like this. Okay, so it would be this area. Okay, and then this is still pi over 3, and then we still use pi over 3. Not negative pi over 3, because this will work. So basically, it's a circle minus, you can think of it as a mustache. It would be, and you get this shaded region. Okay. That's what we're going to get. That's what we're looking for. Uh, so we know that the area of a circle is pi r squared minus this is going to be 1/2 from, what is it, 5 pi over 3 to pi over 3. And then it's going to be circle minus the cardioid, right? It's going to be 3/2 squared minus 1 plus cosine theta square d theta. Okay, so we know that the radius is 3/2, so it's going to be pi half 3/2 square minus 1/2. And then you can pause the video, but go ahead and take the integration of this. And well, you know that 3/2 is 9/4 minus 1. You square this whole thing, you should get 1 plus 2 cosine theta plus cosine square theta d theta. And then FOIL out this minus 1, FOIL out this minus, so that's minus -1 minus -2 cosine theta minus cosine square theta. And when you take the integration and simplify, you should get this. So if you need to pause the video, I'm going to skip that step because you should know. You should get 3 pi plus 2 radical 3 plus -8 pi plus radical 3 all over 4. And you get, so over here, 3/2 squared is 9/4 pi minus 1/2. And when you put all this in the calculator, you should get 7.03870, which is about, put it all in the calculator, you should get 3.549. Okay, that was the last example of that one. And then let's briefly talk about arc length for polar function. So arc length for polar function, for a rectangular, it's the limit equals a to b of square root of 1 plus dy over dx squared of dx. And then the arc length for a polar is the integration from a to b of square root of small r squared plus small r prime squared. Okay, so go ahead and write those formulas because we're going to do only one example. So example 1 says find the length of the curve for r equals 5 cosine theta from 0 to 3 pi 4. So if you recall, this is a rose curve, right? With only one petal. So it would look something like this. And our lower is 0 and our upper is 3 pi over 4. So L equals 0, 3 pi over 4. And you're going to get square root. So we're going to use, I think we're going to use this one, right? So my R is 5 cosine theta, so we have to square that. So that's going to be 5 cosine theta squared plus, what is R prime? Because we need that. R prime is going to be negative 5 sine theta. So it's going to be negative 5 sine theta squared d theta. Okay, so when you kind of clean this up, this is going to be 25 cosine square theta plus 25 sine square theta d theta. And you could factor out a 25, right? So, and then you also know that, so if you factor out a 25, this would be cosine square theta plus sine square theta d theta. And what do you know about sine square theta and cosine square theta? That is an identity that's one of your Pythagorean identity, which becomes 1. So reality is limit equals, not limit, arc length is going to be 0 from 3 pi over 4. And really it's just the square root of 25 d theta. We know the square root of 25 is 5, and then what's the integration of 5? 5 theta. And when you do your upper and your lower, so 0 to 3 pi over 4, it's going to be 5, 3 pi over 4, minus 5 times 0. And when you put it all together, your arc length is going to be 15 pi over 4. Okay, so that is your final answer. Okay, so that wraps it up for the video lecture.